All right, so we're diving deep today into a story that's, well, frankly, unbelievable.
Oh, yeah.
It's about the Voyager probes
Yeah.
and
Voyager? Yeah.
the shocking discoveries they made at the edge of the solar system.
Well, where are we shocking?
I mean, really, just picture this for a second. November 2023.
Okay.
Silence from Voyager 1. Nothing but gibberish.
Oh, wow.
After nearly half a century in space, after billions and billions of miles,
Right.
it really looked like the end for this legendary spacecraft.
Yeah, I can imagine.
But then the team at NASA,
Incredible people.
yeah, they did something incredible.
What did they do?
They made what they called a bold decision.
Okay.
They decided to rewrite code.
Wow.
And not just any code.
Yeah.
This was code that was controlling this essential system on Voyager 1.
I see.
And they had to do it across this immense 22-and-a-half-hour round-trip signal delay.
That's wild. 22 and a half hours to send a message and get a response.
Exactly. It took months of intense work. But you know what?
What?
In April 2024,
Okay.
they brought it back.
They brought Voyager back.
Voyager 1 was back online transmitting data.
That's incredible. A real testament to human ingenuity.
It really is. It makes you wonder what was so vital about this mission, you know?
Yeah. What was so important that they were willing to take such a risk?
And what exactly did these little probes uncover out there in the cosmic wilderness after all these years?
Yeah. What secrets did they find at the edge of our solar system?
Well, that's what we're going to find out today.
I'm excited to dive in.
Me too. So let's rewind a bit.
Okay.
Go back to the beginning. The Voyager mission was initially planned for just 4 years.
Just 4 years.
I know, right? It was supposed to study just Jupiter and Saturn.
Wow. And it's still going almost 50 years later?
I know, it's unbelievable.
Okay.
But here's the thing. Back in the late 1970s, there was this really rare alignment of the planets.
Oh, yeah. I've heard about this. A once-in-a-lifetime event.
Yeah, once every 175 years to be precise.
Yeah.
Jupiter, Saturn, Uranus, and Neptune all lined up in a way that made this grand tour of the outer solar system possible.
So it was a golden opportunity that NASA just couldn't miss.
Exactly. They realized they could use the gravity of each planet to slingshot these probes further and faster than ever before.
Like a cosmic pinball machine.
Exactly. And Voyager 1 was the speed demon right from the start.
How fast was it going?
It reached a blistering 38,000 miles per hour.
Wow, that's incredibly fast.
Voyager 2 wasn't far behind at 34,360 miles per hour.
Still blazing fast.
Oh, yeah. And just 2 weeks into its flight, Voyager 1 captured this iconic image.
Which one?
The one of Earth and the Moon together.
Oh, yeah, I've seen that photo. It's incredible.
It really is. Our entire planet and its moon seen from 7.2 million miles away.
It really puts things in perspective, doesn't it?
Absolutely. It shows you just how vast space really is and just how small we are in comparison.
Makes you feel kind of tiny.
Yeah, a little bit.
Uh.
But it also gives you the sense of awe at the scale of this adventure that Voyager was embarking on.
So where did Voyager 1 head to first?
Jupiter. It arrived there in 1979, and that's when the discoveries really started pouring in.
What did they find at Jupiter?
Well, first of all, both Voyagers revealed that Jupiter has faint rings.
Rings? Really?
Yeah, not as prominent as Saturn's, but definitely there.
I had no idea.
And they also discovered 3 new moons orbiting Jupiter.
So they were adding to our knowledge of the solar system right from the get-go.
Absolutely. And they gave us these incredible close-up views of Jupiter's major moons, like Io, Europa, Ganymede, and Callisto.
Those are the Galilean moons, right?
Exactly. The ones Galileo discovered back in the 1600s.
Then Voyager was giving us our first real close look at them.
Right. And what they saw challenged some long-held assumptions.
Like what?
Well, for example, Ganymede was confirmed to be the largest moon in our solar system.
Bigger than Titan?
Yep. Even bigger than Saturn's moon Titan. It's absolutely massive.
Wow, I always thought Titan was the biggest.
Nope. Ganymede takes the crown.
That's amazing. What about Europa? Did Voyager find anything interesting there?
Oh, yeah. Europa was a big one. The images Voyager sent back show this icy surface covered in cracks and fissures. And scientists started to think, hey, maybe there's something going on beneath that ice.
Like what?
Like maybe there's a subsurface ocean.
An ocean under the ice.
Yeah. It's pretty mind-blowing, right?
It is. That means there could be liquid water on Europa.
Exactly. And as we know, liquid water is a key ingredient for life as we know it.
So Europa could potentially have the conditions necessary for life.
That's the thinking. And this is something we've actually discussed in previous deep dives on this channel.
Right. I remember that Europa's a really intriguing place.
It really is.
Yeah.
And let's not forget about the Great Red Spot.
Oh, yeah. Jupiter's famous storm.
Voyager gave us the first detailed images of this colossal storm.
It's huge, isn't it?
It's bigger than our entire planet, and it's been raging for centuries at least.
Yeah, it's mind-boggling centuries.
I know. And seeing those images really drove home the sheer power and scale of the forces at play in our solar system.
So after Jupiter, where did the Voyagers head next?
Onto Saturn. They used Jupiter's gravity as a slingshot to propel them towards the ringed planet.
And did they make any discoveries at Saturn?
Oh yeah, tons of them. But before we get into that, this is where the paths of Voyager 1 and Voyager 2 diverged.
What do you mean?
Well, by the time they reached Saturn in 1980 and 1981, the mission had already exceeded everyone's expectations.
Right. They were only supposed to last 4 years.
Exactly. But NASA had this incredible foresight. They designed the trajectories of the probes so that they could potentially explore even further.
So they were already thinking about Uranus and Neptune?
Yeah, but there was a key decision to be made.
What was that?
It involved Saturn's moon.
Titan. Titan. The one with the atmosphere.
Exactly. It's the only moon in our solar system known to have a dense atmosphere.
So it was a prime target for exploration.
Oh yeah, scientists were really eager to learn more about it.
So what was the decision?
They had to decide which Voyager would get to make a close flyby of Titan.
And which one did they choose?
They chose Voyager 1.
Okay.
Now this was a scientifically valuable opportunity, but it meant that Voyager 1 wouldn't be able to continue on to Uranus and Neptune.
Ah, so that's why they diverged.
Precisely. Voyager 1's trajectory after Titan would take it out of the plane of the solar system.
And Voyager 2 was free to continue on to the ice giants.
You got it. It was a trade-off with huge consequences for the overall mission.
So what did Voyager 1 find at Saturn?
Well, first of all, it sent back these stunning images of Saturn's rings.
I bet they were amazing. Saturn's rings are just so beautiful.
They truly are. Voyager 1 revealed that there are hundreds of individual rings.
Hundreds.
Yeah, and there are all sorts of intricate structures and patterns within the rings.
Like what kind of structures?
Well, there are these gaps and divisions, braids and kinks.
It sounds so complex.
It really is. And it was all far more complex than scientists had anticipated.
What else did Voyager 1 find at Saturn?
It also discovered 4 new moons orbiting Saturn.
Wow. So they were adding to our moon count again.
Yep. And one of the moons that really captured everyone's imagination was Mimas.
Why I mean this?
We'll take a look at this image.
Oh, wow.
It's heavily cratered, and it has this one massive crater called Herschel.
It kind of looks like the Death Star from Star Wars.
Exactly. That's what everyone thought when they saw it. It's this uncanny resemblance.
That's so cool.
It is. So Voyager 1 made all these incredible discoveries at Saturn, but then came Titan.
The moon they chose to prioritize.
Yeah. And it turned out to be a bit of a letdown.
Why? What happened?
Well, Titan has this incredibly thick and hazy atmosphere.
Okay.
And it was so opaque that Voyager 1 couldn't see the surface at all.
Oh, no. So all those hopes of seeing what was down there were dashed.
Yeah, it was a bit disappointing. But even though we couldn't see the surface, Voyager 1 was still able to gather valuable data about Titan's atmosphere.
What kind of data?
One of the most interesting findings was that Titan's temperature is incredibly close to the triple point of methane.
The triple point of methane. What's that?
So you know how water on Earth can exist as ice liquid or vapor, depending on the temperature and pressure?
Yeah, of course.
Well, methane is the same way. It has a triple point where it can exist in all 3 states simultaneously.
Really?
Yeah. And on Titan, the temperature and pressure are just right for methane to exist as a solid, a liquid, and a gas, all at the same time.
That's so strange.
I know, right?
Mhm.
It suggests that there could be some really complex weather and geological processes happening on Titan involving methane.
Like methane rain and methane lakes.
Exactly. It's a truly alien world, and we only got a glimpse of its complexity thanks to Voyager 1.
So after Titan, Voyager 1 was flung out of the plane of the solar system.
Yeah, Saturn's gravity acted like a giant slingshot, giving Voyager 1 a massive speed boost.
So it became the fastest human-made object at that time.
Yep, it was officially the fastest thing ever built by humans.
Amazing. And meanwhile, Voyager 2 continued on its grand tour to Uranus and Neptune.
That's right. So Voyager 1 set the speed record, while Voyager 2 became the ultimate explorer, reaching the farthest planets in our solar system.
What did Voyager 2 find at Uranus?
Well, it arrived at Uranus in 1986, and it turned out to be a very different kind of planet than Jupiter and Saturn.
How so?
Well, Uranus is what we call an ice giant.
An ice giant? What does that mean?
It means that its interior is mostly made up of these ices.
Like water ice.
Well, not just water ice. It's also made up of ammonia, methane, and hydrogen sulfide.
All frozen together.
Yeah, and all of that is beneath this thick atmosphere of hydrogen and helium.
So it's not a gas giant like Jupiter and Saturn?
Nope, it's a different beast altogether.
Yeah.
And another surprising thing about Uranus is that it's incredibly cold.
Colder than Neptune, even though it's closer to the sun.
Yet, Uranus holds the record for the coldest planetary atmosphere in our solar system.
Wow, that's pretty chilly.
It is. So Voyager 2 gave us our first real look at this strange and icy world, and then it continued on to Neptune.
What did it find there?
Voyager 2 reached Neptune in 1989, and it sent back the first detailed images of this distant planet.
And what did Neptune look like?
Well, initially it appeared to be a very vibrant blue in the early images.
Blue.
Yeah, but later analysis revealed that its true color is more of a teal.
Teal. That's interesting.
Yeah, it's still very blue, but it has a bit of a greenish tint to it.
I wonder why the early images were so blue.
But it probably had something to do with the way the cameras were calibrated and the filters that were used.
Makes sense.
But anyway, Voyager 2 gave us our first real glimpse of Neptune and its moons, and then it continued on its journey out of the solar system.
So what was Voyager 1 doing all this time while Voyager 2 was exploring Uranus and Neptune?
Well, after its encounter with Saturn, Voyager 1's mission shifted a bit.
How so?
Its primary mission became studying the interplanetary environment.
Okay.
It was heading out of the solar system, and scientists wanted to learn as much as they could about the space between the planets.
So it was no longer focused on planetary encounters?
Not really. Its cameras were actually powered down to conserve energy.
Oh, wow.
But before they were turned off, Voyager 1 captured one last, truly iconic image.
Which one?
The pale blue dot.
Oh, yeah, I've seen that one too. It's a very moving photo.
It really is.
Yeah.
From a distance of 3.72 billion miles, Voyager 1 turned its camera back towards Earth and took a photo.
And what did it show?
It showed our planet as a tiny pale blue dot suspended in a beam of sunlight.
It's incredibly small in that photo.
It is. Our entire planet reduced to a single pixel, less than 1/10 of a pixel wide.
It really makes you realize just how fragile and precious our planet is.
Absolutely. It's a profoundly humbling image.
Yeah.
And it marked the end of Voyager 1's planetary observations.
So from then on, it was all about studying the space between the planets.
You got it. And the next major milestone for both Voyagers was crossing the heliopause.
The heliopause, what's that?
Well, imagine the sun as this giant bubble.
Okay.
The bubble is created by the solar wind, which is this constant stream of charged particles flowing outward from the sun.
Right, I've heard of the solar wind.
So this bubble of solar wind is called the heliosphere.
Okay.
The heliopause is the boundary of the heliosphere.
So it's the edge of the sun's influence.
Exactly. It's where the solar wind meets the interstellar medium.
The interstellar medium? What's that?
That's the stuff that's between the stars.
Okay.
It's a mix of gas dust and cosmic rays.
I see.
So crossing the heliopause means entering interstellar space.
Wow, that's a huge deal.
It is. It means leaving the sun's protective bubble and venturing out into the galaxy.
So which Voyager crossed the heliopause first?
Voyager 1. It crossed over in August 2012.
Wow, that must have been a big moment for the mission team.
It was. It was a historic achievement. Voyager 2 followed suit in November 2018.
So both probes have left the heliosphere and are now in interstellar space.
That's right. They're both out there exploring the vast unknown region between the stars.
That's incredible. So what have they discovered about interstellar space?
One of the most surprising things they found was that the heliopause is much sharper and more defined than scientists had expected.
What do you mean?
Well, they thought that the solar wind would gradually weaken as it came further from the sun, and that the heliopause would be this kind of fuzzy boundary. But what Voyager found was that the solar wind abruptly changes its properties at the heliopause, creating this very distinct barrier between the heliosphere and interstellar space.
Really? So it's not a gradual transition?
Nope. It's like hitting a wall.
Wow. That's surprising.
It was definitely not what they were expecting.
What else did they learn about the heliopause?
Well, they also learned that the shape of the heliopause is not a perfect sphere.
It's not?
Nope.
Oh.
It's actually more elongated, kind of like a comet with a tail.
Interesting. What causes that shape?
It's caused by the interaction between the solar wind and the interstellar magnetic field.
The interstellar magnetic field.
Yeah, it's this magnetic field that permeates the entire galaxy.
I see.
And it's this interaction that creates the teardrop shape of the heliosphere.
So our solar system is essentially plowing through the galaxy, creating this wake behind it.
Exactly. It's
Yeah.
like a boat moving through water.
That's a cool analogy.
So the Voyagers have given us this whole new understanding of the heliopause and the heliosphere.
And what about the conditions in interstellar space itself? What's it like out there?
Well, it's a pretty harsh environment.
How so?
It's filled with cosmic rays, which are these high-energy particles that can be harmful to living things.
Okay.
And it's also incredibly cold and dark.
Wow. It sounds pretty bleak.
It is. But it's also incredibly vast and mysterious.
And the Voyagers are out there exploring it right now.
They are. And they're still making new discoveries.
Like what?
Well, one of the most recent discoveries was this strange signal that Voyager 1 picked up in 2022.
What kind of signal?
It was this chaotic stream of data.
Chaotic. What do you mean?
It was just a bunch of random numbers and sequences of zeros.
That's odd.
Yeah, and it was coming from Voyager 1's attitude control and articulation system.
What does that system do?
It's the system that controls the probe's orientation in space.
I see.
So for a while, nobody knew what was going on.
They must have been worried.
Oh, yeah, they were. They thought maybe Voyager 1 was seriously malfunctioning.
So what did they do?
Well, they started troubleshooting, and eventually they figured out that the problem was caused by a high-energy particle.
A cosmic ray.
Most likely. It probably struck a sensitive electronic component and corrupted some of the code.
So it was just a random cosmic event?
Pretty much. But it was a close call.
It sounds like it.
Luckily, they were able to fix the problem by sending commands through a backup computer system.
Wow. That's impressive.
It really is. It shows you just how skilled the engineers and scientists who work on this mission are.
So they were able to bring Voyager 1 back online.
Yep, and it's been operating normally ever since.
That's a relief.
It is. But then, in 2023, there was another problem.
What happened this time?
Voyager 1 went silent.
Silent. Completely silent.
Yep, for 5 months, they didn't hear anything from it.
Oh, no. That's even worse than the chaotic data.
It was. It was really concerning.
So what caused the silence?
It turned out to be a problem with the flight data system.
What's the flight data system?
It's the system that collects and transmits all the scientific data that Voyager gathers.
Oh.
And some of the code in that system had become corrupted.
Corrupted.
They think it was probably caused by a cosmic ray or some other kind of radiation.
So another random cosmic event.
Yep. But this time it was much more serious.
Because it affected the system that transmits the data?
Exactly. Without the flight data system, Voyager 1 was essentially blind and deaf.
So what did they do?
Well, at first, they weren't even sure if they could fix it.
It must have seemed hopeless.
It did. The code was corrupted and they couldn't just send up a repair crew.
Right, they were billions of miles away.
But they didn't give up. They kept working on it, and eventually they came up with a plan.
What was the plan?
They decided to try and rewrite the corrupted code.
From Earth?
Yep, across that 22.5-hour signal delay.
That sounds incredibly difficult.
It was like performing brain surgery on a patient who's on the other side of the world.
Wow, so how did they do it?
Well, they had to be incredibly meticulous.
Of course.
They had to figure out exactly which parts of the code were corrupted, and then they had to write new code to replace it.
And then they had to send that new code to Voyager 1.
Exactly. And they had to do it perfectly because if they made even a small mistake, it could have permanently bricked the spacecraft.
Bricked? What do you mean?
It means that it would have become unusable, like a brick.
Oh, wow. So the stakes were incredibly high.
They were, but they went ahead with it anyway. And it worked.
It worked.
Yeah. In April 2024, after months of intense work, they successfully rewrote the corrupted code, and Voyager 1 came back online.
That's amazing.
It really is. It's a testament to the ingenuity and perseverance of the mission team.
So Voyager 1 is still operating today?
It is.
Yeah.
It's been sending back data ever since it was brought back online.
That's incredible. It's almost 50 years old.
I know. It's amazing how long these probes have lasted and how much they've taught us about our solar system and beyond.
So where are the Voyagers headed now?
Well, they're both continuing their journey out of the solar system.
And where will they end up?
Well, technically, they'll just keep traveling through interstellar space forever.
Forever?
Yeah, unless they run into something.
Like what?
Well, like another star or a black hole or maybe even another civilization.
You never know.
But in the shorter term, Voyager 1 is headed towards a star called AC plus 793888.
Where's that?
It's in the constellation Ursa Minor.
Okay.
Voyager 1 will make its closest approach to that star in about 40,000 years.
40,000 years. Wow, that's a long time.
It is. And Voyager 2 is headed towards a star called Ross 248.
Where's that one?
It's in the constellation Andromeda.
Okay.
And Voyager 2 will make its closest approach to that star in about 40,000 years as well.
So they're both on very long journeys.
They are. But even though they're headed out of the solar system, they haven't actually left it yet.
What do you mean?
Well, our solar system is thought to extend much further than the planets.
How much further?
Well, there's this hypothetical region called the Oort cloud.
The Oort cloud, I've heard of that.
It's this vast spherical cloud of icy objects that surrounds the solar system.
And it's huge, right?
It is. It's thought to extend out to about 100,000 astronomical units.
An astronomical unit is the distance between the Earth and the Sun, right?
Yep. So the Oort cloud is really, really far away.
It is. And the Voyagers haven't reached it yet.
Nope. It'll take Voyager 1 about 300 years just to reach the inner edge of the Oort cloud.
300 years.
And it could take another 30,000 years to pass through it.
Wow. So the Voyagers are still very much within the realm of the Sun's influence?
They are, and they'll be carrying a little piece of Earth with them wherever they go.
What do you mean?
Well, both Voyagers are carrying golden records.
Golden records? What are those?
They're these phonograph records that contain sounds and images of Earth.
What kind of sounds and images?
Well, there's music from different cultures and eras, greetings spoken in different languages, sounds of nature, and even a diagram showing the location of Earth in the galaxy.
Wow. It's like a message in a bottle to any extraterrestrial civilizations that might find them.
Exactly. It's a time capsule of humanity.
And who knows, maybe someday, billions of years from now, some alien civilization will stumble upon one of these golden records.
And they'll get a glimpse of what life was like on our little blue planet.
It's a beautiful thought.
It is. And it's just one more amazing thing about the Voyager mission.
So these little probes have truly made history.
They have. They've explored the outer solar system, they've entered interstellar space, and they're still going strong.
It's an incredible legacy.
It really is. And it makes you wonder what other amazing discoveries are out there waiting to be made.
Well, hopefully we'll get to find out with future missions like the Interstellar probe.
The Interstellar probe, what's that? It's a proposed mission that aims to travel even further than the Voyagers.
Really?
Yeah, it's still in the early planning stages, but if it gets funded, it could launch sometime in the 2030s.
Wow. That would be amazing.
It would.
Yeah.
And it would build on the incredible foundation laid by the Voyagers.
So the future of space exploration is looking bright.
It is. There's still so much out there to discover, and I can't wait to see what we find next.
Me too. And who knows, maybe someday we'll even find evidence of life beyond Earth.
That would be the ultimate discovery.
It would. It would change everything.
It would. Well, that's all the time we have for today, but thanks for joining us on this deep dive into the Voyager mission.
It was a pleasure.
And be sure to check out our next episode where we'll be exploring another fascinating topic from the world of science and technology.
Until next time.
Keep exploring.